Hello, everybody. Good afternoon. Today, we, Team 6 from Group 120, will present to you our PIA presentation, which is about our STEM project, Street Solver. Now, we'll present ourselves.
I'm Fernando Martinez Espinosa. I am Carlos Gabriel Velasquez Canales.
I am Santiago Mancio Velasquez.
Jorge Luis Pelaza Tobar.
And I am Juan Alejandro Casasay.
Today we will present our STEM project. We will go over the introduction, which is where we present our main problem and our protocol solution, the research question, our sustainable development goals, our objectives for the project, our justification for the project, the theoretical framework, which is research we collected from previous studies, hypotheses and definition of variables, the methods we use, the methods used to collect data, the results, which are presented in graphs, the 3D design of the prototype, the conclusions, the discussion, the ICT and DAT, and finally the bibliography.
Now, to introduce our project, we'd like to mention that one of the biggest problems our project seeks to solve is the potholes, which represent large obstacles and risks in the streets today, especially causing accidents. Now, although there's already been some solutions stated before, like the ARES or Autonomous Road Repair System, this lacks a little bit of space and is very time consuming. And that's why our prototype seeks to find an alternative solution, which will be capable of doing it faster, efficiently, and can be done anywhere and at any time.
Well, so our research question will be, what technological and regulatory change must be addressed to successfully deploy an autonomous pothole repair vehicle in urban environments? The SDGs will be sustainable cities and communities and affordable and clean energy. Well, affordable and clean energy because our prototype is mainly its main source is electrical energy, and sustainable cities, well, because for this project it will improve the quality of the streets.
Our objectives are, our general objective is to improve the conditions of streets and reduce the amount of risks that are present in it, between potholes and such. Our specific objective is to fill and fix potholes in the street with materials already defined over 3 months. And our second specific objective is to analyze the technological limitations of the development of this project and seek for a breakthrough to fully establish it as a solution to potholes and streets. For justification, as we have already discussed, potholes are a major risk in Mexican streets. And as such, our project seeks to eliminate these potholes and make streets safer for everyone.
Now, for our theoretical framework, we'd like to establish our main problem, which, as stated before, is a large amount of potholes in streets, as well as the bad conditions due to either excessive rain that is not cleared out or cleaned out, or bad maintenance for long periods of time. Now, we'll state the previous solutions, as stated before. One of them is the ARES, which, as stated before, is an AI system which can fix and detect potholes. This was created in 2020 in the UK. And now, for a solution, we decided to create an autonomous road vehicle that can fix potholes, which we name Street Solver, in order to improve the general conditions of the streets in a more efficient and faster way. Now, continuing with the theoretical framework, we'll establish why our solution is better than the others. And that's because it's got better hardware, better software, which not only makes it better control, also more useful than the others, as well as is more like capable of working for several hours straight, including sometimes even 24 hours. Now, based on this, we decided to reach a conclusion in which we believe in the capabilities of our project, as well as its skills and their capability to work and also improve streets in the nearby future.
Well, the hypothesis will be this project will require an autonomous AI system to cope with the detection of potholes, as well as changing the laws to implement it fully within the streets of urban areas, which will fix potholes and make streets conditions better. The variables will be the independent, the volume of potholes, that is quantitative, and the dependent, that will be material needed, that quantitative. This will be the flow chart. Here we organize the information, the general, like the hypothesis, objective, classification, type of research, variables, and the research question.
Now for methods, we decided to obtain information through a survey, which is a quantitative method. And we used applied research to create a model of our project.
Now, the results of said survey. In this survey, we had how frequently have you had troubles with potholes in the last 3 months? Here, 40% of the people we surveyed say they often had problems with potholes. A small part say they always had problems with potholes. And sometimes a great part of the people had sometimes trouble with potholes. In our second question will be, what would be your acceptance to an autonomous robot repairing potholes? A lot of people say they will be accepting of a prototype repairing potholes in the streets. While a great part, almost a fourth of all the people we surveyed, say they will be completely in favor of this prototype repairing the potholes in the streets. Our results. How many times have you seen workers repairing a pothole or making streets better? A lot of the people say that 1 to 5 times they've seen someone repairing the potholes. A small part say they've never seen someone repairing the potholes. And a small part, almost the fourth of the people we surveyed, think they've seen repairing people the pothole. They've seen someone repairing the potholes 6 to 10 times. How many hours in traffic have you experienced due to the potholes in the streets? A lot of people have faced up to 2 hours in traffic due to the potholes. 3 hours is also an average, with almost a 4% of the people facing potholes. 1 hour is the most time all the people we surveyed has faced in the traffic due to potholes. While a smart part with 4 to 5 hours in traffic due to potholes. Now, the last results. How much does rain affect the conditions in the potholes? 3, 4, and 5 were the results. Most of the people think that it's very affecting, the rain affects a lot the conditions in the streets. How much do you believe in this project for fixing the streets and making it better overall? A lot of people believe in our project to make the streets better. The 3D design. This is a 3D design of an early prototype of this project. Here we face a small vehicle with 4 wheels and a compartment in the inside to store the material and the hardware that make the robot work. And here compartment that holds the materials and the hardware inside. Now, the prototype, the circuit. Here we face the brain of the project, which is an Arduino Uno, a simple project everyone can handle, everyone can buy, accessible for everyone. This is our energy, a battery, 4 AA batteries. This is a protoboard. This is a component, that L290 3D component. This to manage the motors, a microservo motor, and an ultrasonic sensor. How do this work at all? This is a sensor. This checks the distance that it has from something to the nearest object. How would this work with our project? It will be facing down and it will be checking the distance to the street to the model. If the distance becomes irregular, it means there is a pothole there. Therefore, it can stop moving the motors and open the compartment that search for the material to fix the pothole. All this project is accessible for everyone, therefore making it easy for the streets to be solved and there being no excuse for potholes to exist in the streets. A prototype with the video. This is our prototype and the conclusions.
This is my fitness conclusions, but I need the other side. Alright. Thank you. I really enjoyed this project because I got to innovate and design in new apps such as Sway, Excel, OneDrive, and Tinkercad, and just being able to, work creatively in these areas has really opened my mind towards how much potential 3D design, 3D printing has, and I just really liked to be able to work with my team to make this project. It was a really nice experience, and I hope that this prototype can be used towards the future of the safety of the infrastructure of our cities.
Now, for our discussion, we'd like to discuss what this project brings to us. It was able to generate knowledge, and with that knowledge, we were able to apply it thanks to the learning units of facts of knowledge, scientific methodology of research, information communication technology, development of abstract thinking, and English in action. Now, we also like to discuss that from our experience, we're able to develop many skills. Some of them being organizing time, designing in 3D, programming and coding, developing circuits as my like a team member mentioned, and also, and most importantly, developing skills like teamwork and good communication, which makes us believe that our project can, in the nearby future, change how we view the world.
ICT. Can robotics be applied to the improvement of this prototype? Specifically, yes. The entirety of our prototype is robotics. It has sensors, it has batteries, it has the hardware, which is the brain of these components. In conclusion, yes, this prototype is entirely composed of robotics. Robotics itself will help this prototype.
And now for the DAT learning unit or development of algebraic thinking learning unit, we answered two questions. The first being, did your mathematical results help to confirm or reject your hypothesis? In our case, it did help to confirm it, since the results we obtained help to indicate that normally people struggle with puzzles daily, and they will accept the idea that our autonomous vehicle robot will prepare them. And for our second question, which will be, what will be your conclusion about the mathematical results contribute to confirm or reject your hypothesis? Well, in this case, we concluded that our problem, as we believed before, is very frequent, and the project had the acceptance we expected. So with this, we were able to, thanks to the surveys, gather the information necessary and numeric data to confirm our hypothesis. And with this, we believe in our prototype for the future. And this is a bibliography which contains where we gather all the information during the realization of our project. And that will be all for today. Thank you for your attention.